So what I want to talk about is this idea called independence. And what this basically says is that A and B, if you have two events, A and B, they don't affect each other's probabilities. A stronger pen here. They don't affect each other's probability. Another way of putting it, the probability of event B occurring, given that A has occurred, well, still going to be the probability of B if A hasn't occurred. Likewise, the probability of A occurring, given that B has occurred, it's going to be the exact same probability as if event A just occurred on its own. So the presence of these other events, they don't affect each other. So let me give you an example of this, of independence and dependence. So for example, let's say we're going to draw numbers from a hat. So it's numbers 1 through 10. We're going to draw these from a hat. Now, what we're going to do this with replacement. The idea here is this. When we pull a number from a hat, let's say it's on these little tickets, we put the ticket back in. We just note what number we pulled and we put it back. So let's say for the first ticket here, we're going to pull, what's the probability of 3 on first draw? So what's the probability of pulling a 3 on the first draw? Well, how many tickets are there? What's our sample space? Well, our sample space is numbers 1 through 10. These are all whole numbers. So there's 10 elements in the sample space. Now, how many tickets have a number 3 on them? Well, there's only one. So there's only one ticket with a number 3. So we get a probability of 1/10. So now we put that ticket back in. Now we ask the question, what's the probability of getting, say, a 5? So let's say we want to ask, instead of getting a 3 on the first draw, what if we wanted to get a 5? Well, again, there's 10 tickets. And only one of them has the number 5 on it. So again, it's 1 out of 10. So let's change things up. Let's say we want to know the probability of a 5 on the second draw given we got a 3 on the first draw. Well, what this says is on the first draw we drew a 3. but we put that back in. So when we get to the second draw, how many tickets are actually in the hat? Well, there's still 10. We drew a 3 and we put the ticket back. So we have 10 in the hat still when we get to the second draw. And so how many 5s are available? Well, there's only one ticket with a 5. So it's 1 out of 10. So here's the thing. The probability of a 5, given that we drew a 3 first, is just the probability of drawing a 5 first. In other words, it doesn't matter what happens before, the probability of drawing a 5 will always be the same, 1 out of 10. So this is an idea of independence. Now, dependence is different. And I should probably add in the notes. Here, I'll clarify that. The P of drawing a 5, given that you draw a 3 first, with the probability of just drawing a 5 first without any 3 being drawn before, and that was again 1/10. Got the same thing. So let's look at dependence. Now for dependence, here it does matter if an event happened first. And so the way to describe this is, again, we're going to draw. Let me see with a slightly stronger pen. Let's say we're going to draw, again, numbers 1 to 10 from a hat. And what we're going to do now is we're going to not use replacement. Without replacement. So this means we draw a number and we toss it out. So again, if we draw a 3 first. Well, the first draw, there's still 10 tickets. There's only one of them that has a 3 on it. We get 1 out of 10. Same thing for drawing a 5. If you draw a 5 on the first draw, well, in that first draw, there's 10 tickets. Only one of them has a 5. But now let's combine things. The probability of drawing a 5 on the second draw, given you drew a 3 on the first draw. So here's the thing. Now we're not replacing the tickets. We're throwing them out. So if we draw a 3 on the first draw, we take that ticket and we toss it. Now originally there were 10 tickets. Well, if we toss one of them, that means there's only 9. So we start out with 10, we draw a 3, we toss that one out. Now we go to round 2. In round 2, there are only 9 tickets. Now, of those 9 tickets, only one of them is a 5. So it's 1 out of 9. But here's the thing. If we just draw a 5, it should be 1/10. But if we draw a 3 first and then draw a 5, now the probability of drawing a 5 has changed to 1/9. So that means when we do without replacement, we have a dependent situation. The probability of drawing a 5 will depend on the event that happens before, or if there's an event that occurs before. So that's the idea of dependence and independence. So if you have any questions, let me know.